In this video, we will learn how to find limits at infinity. What is a limit at infinity? Let L be a real number. F of x approaches L as x increases without bound. That is, as x approaches infinity and is denoted by limit of f of x approaches infinity is L. This statement means that for each epsilon greater than 0, there exists a positive number m such that the difference between the function value f of x and L is always less than the epsilon whenever the x is bigger than m, when the x is here. Let L be a real number and f of x approaches L as x decreases without bound, that is, as x approaches minus infinity, and is denoted by limit of f of x approaches minus infinity is L. This statement, limit f of x as x approaches minus infinity is L, means that for each epsilon there exists n, now a negative number less than 0, such that the difference between the function and this number is always less than epsilon whenever the x chosen less than n. Next is how to find the limit of rational function at infinity or minus infinity. So first step is you substitute x equal to infinity or x equal to minus infinity, whichever is given. If both the numerator and the denominator approach infinity, then divide both the numerator and the denominator by the highest power of x in the denominator. And then you simplify and substitute x equal to infinity or x equal to minus infinity again, and then simplify using the facts. Infinity divided by a number is infinity. Any number over infinity or infinity to the any power is 0. Horizontal asymptotes. The line y is equal to L is a horizontal asymptote of the graph of x whenever the limit of f of x as x approaches infinity is L, or limit of f of x as x approaches minus infinity is equals to L. Let's say example number 1. So we're going to find the limit of x squared plus 2 over x cubed minus 1 as x approaches infinity. So the first step is we're going to substitute x equal to infinity with the axis. So you will have infinity squared plus 2 over infinity cubed minus 1. Now remember, infinity to the power, any power is infinity. So you have infinity here and plus to infinity minus 1. So if you add a small number like 2 into infinity, it's going to stay infinity. Remember, infinity means a very, very large number. Now if you subtract 1 from the infinity, it's not going to affect the infinity, so you have infinity. So now we have an infinity on the numerator and infinity on the denominator. So as per guidelines, now we're going to divide the numerator x squared plus 2 and x cubed minus 1 by the highest power of x in the denominator. Now highest power of x in the denominator is x cubed. So therefore we're going to divide x squared plus 2 by x cubed and x cubed minus 1 over x cubed. And next thing is we're going to simplify. How are we going to simplify? We're going to divide each of these by x cubed separately, and same thing on the denominator, and we will get this limit x approaches infinity, x squared over x cubed plus 2 over x cubed. So on the denominator we'll get x cubed over x cubed minus 1 over x cubed. So now we simplify, so you'll get 1 over x plus 2 over x cubed, and the denominator gives you 1 minus 1 over x cubed. So now we substitute again x equal to infinity. Remember, when you substitute, we don't write this part of the limit. So you have 1 over infinity plus 2 over infinity cube minus 1 over infinity cube. Now remember, any number divided by infinity is 0. So 1 over infinity becomes 0. 2 over infinity q also becomes 0. 1 stays 1 and 1 over infinity q becomes 0. So now you have 0 plus 0 is 0. Yeah, 1 minus 0 is 1. So now 0 divided by is 0. So the answer to this question is 0. Example 2. Now we're going to find the limit x approaches infinity, x squared plus 2 over x squared minus 1. So again we substitute as per guideline x equal to infinity in the function. So this becomes sigma square plus 2 sigma square minus 1. So sigma square is sigma plus 2 and sigma square becomes sigma minus 1. So the result would be sigma infinity plus 2 is infinity over infinity minus is 1 is also infinity. So we have again infinity in the numerator, infinity in the denominator. So as per guideline, we're going to divide the numerator and denominator by the highest power of x in the denominator. Now highest power of x is x squared. So we're going to divide the numerator x squared plus 2 by x squared and then x squared minus 1 by x squared. And then we simplify, which basically means we divide each by x squared, each term by x squared separately. So you get x squared over x squared plus 2 over x squared. Similarly on the denominator, x squared over x squared minus 1 over x squared. So now we simplify. So you get x squared is 1, 2 over x squared stays. Again, x squared over x squared again become 1, and you have 1 over x squared. Now we substitute x equal to infinity because of this infinity. So you will have 1 plus 2 over infinity square, 1 minus 1 over infinity squared. Now remember, number divided by infinity to the any power is 0. So you have 1 plus 0 over 1 minus 0. Now 1 plus 0 is 1 and 1 minus 0 is also 1. And 1 over 1 is 1. So the answer is 1. Example 3. So now we're going to find the limit of x squared plus 2 over x minus 1 as x approaches infinity. So we're going to do the same thing, substitute x equal to infinity with the x's. So you will have sigma infinity square plus 2 and infinity minus 1. Now infinity square is infinity plus 2. So now infinity plus 2 stays infinity. Infinity minus becomes infinity. Again we get infinity over infinity. So therefore we're going to divide the numerator and the denominator by the highest power of x in the denominator. The highest power of x is x. So we're going to divide the numerator x squared plus 2 by x and x minus 1 by x. And then we divide individually like x squared over x and 2 over x, and similarly here x over x minus 1 over x, and we have this. Now we simplify x squared x is x plus 2 over x over x becomes 1 and so minus 1 over x. So I substitute x equal to infinity again. So you will have x becomes infinity, this 2 over infinity, 1 minus 1 over infinity. So now number divided by infinity is 0. So you have infinity plus 0 on the top and you have 1 minus 0 on the bottom. The infinity plus 0 stays infinity, 1 minus 0 stays 1. Now we have infinity over 1, so which is 1. So either you say infinity or you say DNE. DNE stands for does not exist. So here is an example 4. So now we're going to find the limit x approaches infinity to x minus 3 over this square root of 3x squared plus 1. So first thing we do is the same thing. If you do substitute x equal to infinity, so you have a 2 times infinity minus 3, which is infinity. And if you substitute here, you still get infinity over infinity, which means we're going to divide the numerator and denominator by the highest power of x in the denominator. Well, what is the highest power? Here we have a square root. So if you ignore 3 and 1, so you get square root of x squared. Now since x approaches infinity and x is always greater than 0, so we're going to use x square root of x squared. So we're going to divide the numerator by x, and also divide by x, but we're going to replace the x with the square root of x squared. So now we have a 2x minus 3 over x and 3x squared plus 1 divided by the square root of x squared. Okay, so now we're going to simplify. So while now we're going to use this fact, the square root of any number divided by square root of any number is square root of, like square root of a divided by square root of b is the square root of a over b. Okay, so now we have a 2x over x minus 3 over x, and then we count 3x squared plus 1 over x squared. Okay, so now we divide individually under the radical sign. So then we have 3x squared over x squared plus 1 over x squared. Simplify further, so it's x squared cancel, gives you 3 and plus 1 over x squared. So now we substitute x equal to infinity, where the x is. So it's become 2 plus 3 over infinity, 3 is 3, and become 1 over infinity squared. So we use the fact the number divided by infinity is 0. One number divided by infinity square is also 0. So we have a 2 minus 0 over square root of 3 plus 0. So 2 minus 0 becomes 2, square root of 3 plus 0 becomes square root of 3. Now you can rationalize, so the final answer you can put 2 times square root of 3 over the 3. As an example 5. Here we're going to, it's the same function, but we're going x approaches minus infinity now. So we do the same thing. You can see if I substitute minus infinity here, you're going to get infinity over infinity. So this means that we have to divide the numerator and denominator by the highest power of x in the denominator. So if I look at the denominator, you can see if I ignore 3 and 1, you left square root of x squared, which is basically was x. So we're going to divide the numerator and denominator by x. So we'll have this 2x minus 3 over x, square root of 3x squared plus 1 over x. Now we're going to replace x. It depends. So x approaches minus infinity, which means x is always less than 0. So instead of using x equal to square root of x squared, we're going to use minus square root of x squared in this case. So now we have this 2x minus 3 over x, square root of x squared plus 1 over negative square root of x squared. And now we use the same fact, the square root of a of square root of b is square root of a over b. Okay, so you have a 2x over x minus 3 over x, 3x squared plus 1 over x squared. So we simplify the top, so this becomes 2, this stays 3 over x. Here we divide 3x squared over x squared plus 1 over x squared. Simplify this part. So you have in this copy 2 plus 3 over x. This becomes 3 and then 1 over x squared. And you have a minus sign. Now we substitute minus infinity where the x is. So you will have 2 plus 3 over minus infinity. And you have a 3 minus 1 over minus infinity squared. Okay, so same principle, 3 over infinity is 0. 1 over infinity squared is also 0. So you have a 2 plus 0 minus square root of 3 plus 0, which is minus 2 over square root of 3. Now we rationalize, so you'll get negative 2 square root of 3 over the 3. Okay, so now we have example 6. Find the limit if it exists. So we're going to find limit of 3 plus 4 over x approaches infinity. So as usual, we substitute infinity. So you have a 3 plus 4 over infinity. And 4 over infinity is what? 0. So 0, 3 plus 0 is 3. So the answer is 3. So we have example 7 now. So we're going to find the limit of 6x plus 7 over 4x minus sign. So x approaches infinity. So if we substitute, we can see that if we substitute x in infinity, so it becomes infinity over infinity. So that's why we skip that step. So we divide the numerator and denominator by the highest power of x in the denominator, and highest power is x. So we have now 6x plus 7 over x and 4x minus 9 over x. Simplify, we divide individually in the top, so it becomes 6x over x plus 7x plus 4x over x minus 9 over x. Now we simplify. So you get 6 plus 7 over x, 4 minus 9 over x. Substitute x equal to infinity. So you will have 6 plus 7 over infinity minus 4 over 9 infinity. 9 over infinity. 7 over infinity becomes 0, 9 over infinity becomes 0. So you're left with 6 and over 4 when you can reduce to 3/2. So the answer is 3/2. Example 8. The limit x goes to infinity to x squared plus x over 6x cubed plus 2x squared plus x. Okay, so we do the same thing. We can see if I substitute x equal to infinity on top and bottom, you will get infinity or infinity. So you divide the numerator by the highest power of x on the denominator, and that's the highest power of x cubed. So we have 2x squared plus x over x cubed, and on the bottom we have 6x cubed plus 2x squared plus x over x cubed. Now we divide individually. So you got 2x squared over x cubed, x over x cubed, 6x cubed over x cubed, plus 2x squared over x cubed, plus x over x cubed. Now simplify each fraction, and we have 2 over x plus 1 over x squared, 6 plus 2 over x plus 1 over x squared. Now we substitute x equal to infinity. Where the x is, we have a 2 over infinity plus 1 over infinity squared. On the bottom we have 6 plus 2 over infinity plus 1 over infinity squared. So 2 over infinity is 0, 1 over infinity squared is also 0, 6 stays 6, 2 over infinity is 0, 1 over infinity squared is 0. 0 plus 0 is 0, 6 plus 0 plus 0 is 6. So 0 over 6 is 6. The answer is 6. Example 9. We're going to find the limit if it exists. Limit x approaches infinity, sine x over x. Okay, so we substitute with this x's, we limit, or you can use the limit of the fraction is the limit of the numerator and limit of the denominator. Now, well, limit of this doesn't exist because it fluctuates, this one, the graph of sine x between -1 and 1. A limit of x is infinity. So to find when you have a dne on the top, infinity on the bottom, so in that case we have to use some other way to find the limit. So let's use a squeeze theorem. So squeeze theorem says you find two functions between which sine x over x is sandwiched and whose limits are the same. So let's start with this one. Well, let's start with the fact that sine x is between -1 and 1. So we can write sine x is between -1 and +1. So now we divide all this side by x. So you have a -1 over x, sine x over x, 1 over x. And now we take the limit as x approaches infinity. So this becomes limit x approaches infinity -1 over x less than equal to limit x approaches infinity sine x over x less than equal to limit x approaches infinity 1 over x. Now we find the limit, you substitute infinity in only this part and this part. This we know we can't find. So this becomes -1 infinity. So you have a limit sine x over x approaches infinity become 1 over infinity. Number divided by infinity is 0. So it looks like the limit of this is between 0 and 0. So in these two numbers are the same. So we can conclude by the squeeze theorem the limit of sine x over x as x approaches infinity is actually 0. Okay, now we're going to find the limit, if it exists, of limit of x sine 1 over x. So here is a hint, we can use this substitution x equal to 1 over t. So we substitute x equal to 1 over t, and now remember if t is infinity, so 1 over infinity becomes 0. So that means we can replace x approaches infinity to t approaches 0 from the right. So this becomes this limit t approaches 0, x becomes 1 over t, sine and 1 is 1 and x becomes 1 over t. You simplify to this one because sine t, and then you can t right on the bottom. And now we have a limit of sine t over t and t approaches 0. And you probably remember the results from section 1.3 where it says limit of sine x over x as x approaches 0 is 1. So using that fact, the answer to this is 1. Okay, so find the limit of x approaches minus infinity x plus square root of x squared plus 3. You can use the calculator if you want, but here I'm going to find the limit using analytically. So what we do is we can rationalize. We can also rationalize numerator. So in this we can rationalize, which means we multiply this by the conjugate of this. And what is the conjugate of this? You just change the sign of plus. So that's the conjugate, x minus the square root of x squared plus 3. So we write limit x approaches minus infinity, x plus the square root of x squared plus 3 multiplied with the conjugate of this, x minus the square root of x squared plus 3 over x minus the square root of x squared plus 3. Now we can multiply these two. You can see they look like this kind of expression, a plus b, a minus b, which is a square minus b square. So we simply say x square, which is a, and the b is this one to become the square root of x squared plus 3. And this comes on the bottom, x minus square root of x squared plus 3. Now we simplify. Okay, so now we can simplify here, x squared minus x squared cancels, and we're left with negative 3 over x minus square root of x squared plus 3. Now we divide the numerator and the denominator by the highest power of x in the denominator. So that's highest power of x. So we divide minus 3 over x and this x minus square root of x squared plus 3 by x. Okay, so we divide individually on the denominator, so we have a negative 3 over x over x minus square root of x squared plus 3 over x. We simplify this one. Okay, so we substitute x equal to infinity here, so this becomes minus 3 over infinity, and this becomes 3 over infinity squares, and now minus 3 over infinity becomes 0, 3 over infinity squared also becomes 0, so we have 0 over 1 plus square root of 1 plus, and this 1 plus 0 is 1, square root of 1 is 1, so you have a 0 over 1 plus 1, which is 0 over 2, which is 0.